Whether you have an existing site or a brand new site, you should be able to upgrade any existing website, regardless of platform and front-end framework, within about 15 minutes to make it meet the guidelines to be a minimal progressive web app. In this video, I'm going to show you how in under 15 minutes you can upgrade an existing website to be a progressive web app. Hey guys, Chris Love, the owner of Love to Dev, and a huge advocate of progressive web apps. Now, a question that I see asked all across different channels, and that could be Stack Overflow or blog post for comments, Facebook, Twitter, is, I know framework X or I know backend Y. How do I make it a progressive web app? Well, the real answer is that has nothing to do with being a progressive web app. The minimal requirements to be a progressive web app are: be served over HTTPS, include a web manifest file, and that web manifest file should have a minimal array of icons for your application. And finally, you need to register a service worker, and that service worker needs to have a fetch event handler. Now I'm going to talk about each one of these in this video, and I'm going to show you how I'm just going to take the HTML5 Boilerplate project and turn it into a progressive web app really quickly. When you're done with this video, you should be able to go to your website project and apply these three principles and very quickly create a progressive web app out of your existing website without having to change anything about the way your website works. Now, if you have not heard of the HTML5 Boilerplate, it has been around for several years as a minimal reference site or page, really, for you to start a project. Now, there are some things that I don't agree with about the way they've done it, and there's a lot of things that I do agree with, way more than I don't agree with, but I think it's a good place for anybody to start who's kind of new to web development, because it does include a lot of the core things that should be in a website. However, the default HTML5 Boilerplate project does not have all the pieces for a progressive web app. So what I have done is I've forked this project, and you can find it on my GitHub profile, and that's github.com/docluv. Under that, you can look for HTML5 Boilerplate-1, and you can find the source code that I'm going to show you here in this video. Feel free to clone it or even fork it for yourself and modify it as you feel free. Now, I'm going to switch over here to Chrome. Now I've made a couple of changes to the default code. First, I made the background color orange, and I also just threw one of the images up here just to give it a little more visual pop, because there's really no content in this boilerplate project, and I kind of wanted something to look at. Now, next you're going to notice that it's being served over localhost and a port. The port here is arbitrarily chosen to be 15,001, and I'm going to show you how I do that here as well. Now, as I mentioned at the first part of this video, there are three key components to make a progressive web app, and these are the technical requirements. These aren't what I would call the user experience requirements. The technical requirements are easy for static analysis, if you will, so that browser tools like Lighthouse or just the heuristics built into the browser can quickly determine, does this meet our minimal guidelines to be a progressive web app? And again, those requirements are: be served over HTTPS, have a web manifest file, and a registered service worker. But it also goes a little bit further. If you notice, sometimes Chrome does not acknowledge a site to be a progressive web app, therefore it does not launch that add to home screen experience that you're really after. And that's kind of the key litmus test, I think, to determine, are you a progressive web app or not? Does your website trigger that add to home screen experience. Now remember, each browser has a slightly different heuristic model, which means it has slightly different guidelines to decide does it meet the progressive web app requirements. They keep the bar fairly low. Now the web manifest file should have have the icons array to have a set of icons that it can use to represent the icon on the application on the home screen. The service worker does need to have a fetch event handler. There's no requirement that that handler does anything, and the reason is because these simple static analysis tools can look for the pattern to where you're registering that fetch event handler or check to see if that's there, but they're not going to go into how complex your logic is to actually manage caching responses and requests. And that's a good thing, at least to get things rolling. Now, the local host aspect of it. Like I said, you do need to serve your website over HTTPS. That requirement is for what I would call production or live domain websites. But when you're developing locally, installing a local host SSL certificate is kind of a pain in the rear. It can be done, and there are local host web servers that have the capacity to do it. However, the people who wrote the spec knew that this would be a big barrier to entry for developers to actually be able to develop and practice service worker debugging. So the service worker requirement actually says, or the specification actually says, that if it's served over localhost, they will relax that requirement for SSL. So for localhost, you don't need the SSL. But if you are deployed to anything other than localhost, you will need an SSL certificate. Remember this if you are deploying to a common QA or development environment as well as your production environment. They will all need SSL certificates. Fortunately, the barrier to acquire and install those SSL certificates has drastically come down in recent years. In the past, that used to be a very expensive and very tedious process. Today, there are many sources of free SSL certificates, and some as low as $5 or $10. Now, there are different types of SSL certificates, and I'm not going to go into that world for this video because it would get rather long. But just keep those things in mind. For our purposes, we're going to be looking at localhost so I can contain this demonstration. Now, personally, I like to use the Node Connect web server for my local development, and I still launch it as a grunt task. There are plugins and extensions available for other task runners like Gulp that will also launch the Connect module, or you could actually write your own script or just launch it from your npm script directly. It's up to you how you want to do that, but I personally like Connect. Now the Chrome team also has a localhost web server available, and there are many other options. For example, if you're using Visual Studio, it comes with a built-in localhost web server that will launch if you hit F5 or Control F5, and your web server is the default project in your solution, yada, yada, yada. But I work with Visual Studio Code, which does not necessarily have that built in, so what I do is I launch Connect from one of the command prompts instead of Visual Studio Code. And let's just go look at how that's set up real quick. Now like I said, I still launch it as a grunt process. So if we go to our grunt file, it has the configuration for the Connect object or module, and I also define a local host here just so I know mentally what it is, because a lot of projects I'll have multiple versions of the actual code that's going to, quote, be distributed, and so I want to test it in those different scenarios first. Now the first thing I do is I define a port. Again, this is arbitrary. I do tend to stay up in the high teens of the thousands, so generally my local host sites are between 10 and 20,000 port. You can go up to port 65,000 something or whatever. Now I'm pointing it to the distribution folder as where the actual website is. Again, this is for this HTML5 boilerplate project. You can direct it how you need to direct it for your project. And just for realistic purposes, I enable keep alives because that is a web performance best practice. And that's really all there is to it. From there, you would just launch it from the command prompt. As you can see, I've already done. Here I've called grunt connect, and it's launched this. Again, launch it however you would like. And just notice when you do launch a web server from the local command prompt, that command terminal is going to be locked up because that is a process that's going to keep running so that it can listen for requests. So you will need to open up another terminal if you need other command prompt access. Okay. Now, the next thing you need to do is you need to add a manifest file. The HTML5 boilerplate project comes with a manifest file included, but it doesn't necessarily meet our minimal requirements, so I enhanced it, and we just get that out of the way. I gave it a name and a short name. These are used to describe or represent your application, and your browser platform, whether it be Chrome or Firefox or Opera or very shortly Edge, will use the name appropriately based on the size available to actually display the text. So typically for your smartphone home screen icon, this short name is what will be used. But in the case of, say, a wide Windows Live tile, I'm pretty sure the full name will be used. Next is an array of icons. You want to make sure these icons are PNG, and the reason is Chrome tends to be fussy if there's not PNG files available. The actual spec doesn't necessarily state that they need to be PNG files, but based on what I've seen in Chrome and actually triggering that add to home screen heuristic, I highly recommend sticking with PNG files. Now I've got quite an array of different sizes, and the way I like to name my images is to give it a common name and then also put the height and width dimensions at the end of it. That way I know just by looking at the name what the actual dimensions of that particular image are. So I've got quite a few. I go up to 600 by 310, and the reason why I go up to some of these images is because they correlate to existing specifications for Windows Live Tile, and I definitely want to be ready for when Edge starts shipping Service Worker and Progressive Web App support later this year. Where we should have the ability to have those wide tiles on desktops for sure. Next, the start URL, because a progressive web app could be added to the home screen from any page within your site. However, the user probably does not want to enter the site from that page every single time because they're thinking about it in terms of an application. And if you think about any native application, you never open the application from cold, if you will, deep within the application to wherever you left off, the day before, 2 days before, an hour before, whatever it may be. And this is how you can definitely define a common start or a home page for your progressive web app launch. Next, how do you want that application to launch from the home screen? Personally, I stick with the standalone because that makes it look like a native application, and it doesn't force it into full screen mode because sometimes you just don't want full screen mode on desktops. Obviously on phones it's going to be full screen, but the standalone mode will trigger it to launch without any browser Chrome. There are other options available. Full screen will basically do the same thing but forces it to be a full screen, back down to browser, which is just like if they open it up as a new browser tab, so you would have full browser Chrome. Next are colors. The background color should correspond to your default background color, and then the theme color can correspond to anything else. The way I tend to do this is I make it the background color, the default background color in the application, and the default font color of my website. Now I've actually got these inversed from this HTML5 boilerplate. Now what I'm going to do is I'm going to go change that real quick. The default color in here is 2222, which is that dark black kind of color. And so what I'm going to do is I'm just going to change it up to make it consistent with that color, because an orange background is just really not that pleasing. Oh, we screwed that up, didn't we? Okay, there we go. Let's just do it this way. And we'll do that. And now if I go back, now it looks a little better. Okay. That's interesting. We got that mark there. I wonder where that came from. Oh, I bet I got something off of my HTML. Let's go fix that while we're here. Yep, there it is. There's the line. Okay. I think that looks a lot better. There we go. Okay. So now our theming, our web manifest file, and our page actually match up. And that's really it for a web manifest file. There are other properties that you can add and define. It's up to you if you want to go that much deeper. I'll have more content available in our Progressive Web App course. They'll go into all the different aspects of a web manifest file. So if you want to learn more about building Progressive Web Apps, be sure to register for our Progressive Web App course. The next requirement is a service worker. Now, the default HTML5 Boilerplate does not have a service worker file, so I did add an sw.js. That is kind of a de facto standard I see used quite often for naming of a service worker file. You can name it whatever you'd like, but I tend to stick with sw.js because it's nice and short. And here I've got a fetch event handler. Now, you do not need to be a master of service worker caching. Well, we do have a course on that as well. But you do need to register a fetch event handler. And you can do that in your service worker file by referencing the self object, which correlates to the global scope in your service worker, and calling the add event listener function just like you would in UI code. The event in this case is fetch, and then you want to pass a callback handler, and that callback handler receives one variable, and that's going to be an event object. Here I've represented it by a contracted EVT name. And what I'm going to do is I'm just going to log out that we had a fetch event. That way we can check our console to see that we're intercepting all the requests. Here I'm not doing anything, so the request is just going to get handed off to the network, and that's just going to be as if we didn't have a service worker there at all. But so we can meet our minimal requirements to be a progressive web app, we're gonna register this. Otherwise, you will get a message from Chrome telling you that the fetch event handler is not there and that your application doesn't work offline. All it's doing is checking to see if this is there. Now, there's one more important piece to the service worker puzzle to get things started, and that's actually registering the service worker. So to do so, you need to add some code to register a service worker. Now I've added it as the last script here. Now remember, this will have nothing to do with your UI thread at all, except that it has to be registered from the UI thread of a web page. But because all browsers don't support service workers, you should do feature detection, just like you should do for any feature that you're trying to actually use that may or may not have what I would call de facto support across all the browser platforms. Now remember, after this fall, Safari will be the only browser that does not support service workers. Internet Explorer doesn't, and it will not, but it is also a deprecated browser as well. But because a lot of people use those browsers, you should always do feature detection. And to do that, you just need to see if the service worker object is a member of the navigator object. And if it is, then you can proceed and register the service worker. And to do that, you need to call the navigator.serviceworker.register function, passing it the path to your service worker. Now it is important that that service worker be in the root of your website. And this gets into how service workers can be scoped, and that's a more advanced topic that I do cover in our service worker courses. But for here, you've got your service worker in the root of your website. And remember, everything related to service workers is based on promises. So this register function is going to return a promise. If it is successful, then the then handler will get executed. If there is an exception, the catch handler will get executed. So basically, if your service worker registration fails, for example, you don't have that fetch event handler, then this message will be logged to your console. If everything is fine, then this message will get logged to our console. So we're not doing anything really fancy. We're just meeting the minimal requirements to trigger that add to home screen experience. And as you see, hopefully, I know you saw when we came back just a few minutes ago, it doesn't just trigger automatically. Sometimes it does wait and then it triggers for us. You'll have a little message up here showing from Chrome to add to home screen, and I believe we can actually manually trigger this. Oh, there it is. It came up for us now. There we go. So it came up because it determined that we met our requirements and the heuristic model matched up. It's going to prompt us to add it to the home screen. Again, this is on my desktop. Obviously, a similar thing would happen if we did it on phones as well. And that's one of the biggest things we're after is the phones, because those have turned into about 80 to 90% of the actual market these days. Now, before we go, I want to walk through the experience in the developer tools just to verify some things. Now, we just looked at the message that's going to get launched when the service worker is registered. As you notice, it's kind of buried down here, and the reason is because this isn't the first run of this particular page. So every single time the page is launched, that register process is going to be triggered. But if the service worker is currently controlling that particular page, it's going to intercept all the requests to the network. And that's why we see all these requests, these logs up here for all those different requests before we see the callback for the registration being successful. Now this gets into service worker lifecycle concepts. Again, we've got a course that deep dives into this concept, and it's a very important concept for you to understand in your path to mastering service workers. So I do highly encourage you to sign up so you can partake in that course as well. Now I want to go over to the application tab. We're going to look at the manifest here. And what it's doing is if you have a valid web manifest, it's going to essentially echo out the parts that it finds. So you can see here's our name, our short name, the start URL, the colors, when the orientation and display. We didn't set the orientation. Depends on the application. You may want to set that to landscape or portrait. I generally make it open. That way they can rotate it. And then here it's showing us each one of the images in the manifest file. If you see an image that is not represented here, basically it's 404, that means you need to go back and look at your references to your images. You may have a typo or something like that, or you may not have that image. And next, let's look at the service worker tab here, and you can see we have a successfully registered service worker. Now I'm going to go into the details of all of the stuff here. Again, we've got more content available on that, but as you can see, you should be able to upgrade any existing website without changing the integrity of that website to be a progressive web app with little to no effort. And this should start you on your journey to be a full-blown progressive web app so that you can delight and engage your customers so that they will engage with your website at a much higher rate, making your business much more happy and profitable. And that makes you a rock star developer for your company. This is Chris Love. I hope you enjoyed this video and found it helpful, and hopefully you'll start your journey to make progressive web apps today.